Here we're going to look at the question, does the cube root of 6 times the square root of 2 equal 12 raised to the 5/6 power? Here's another way of writing the left-hand side of the equation. 6 to the 1/3 power times 2 to the 1/2 power. And what I saw some students doing today in class is taking the least common denominator of 1/3 and 1/2 and rewriting this as 6 to the 2/6 times 2 to the 3/6, and then simplifying that by adding together the two exponents as we do in this rule. Right, but then also multiplying the bases 6 and 2 to get 12 to the 5/6, which isn't correct. So what's an easy way of showing this? The easiest way of showing this is by pulling out a calculator. So 6 to the 1/3 times 2 to the 1/2 to 2 decimal places is 2.57, whereas 12 to the 5/6 is 7.93 to 2 decimal places. So where did we go wrong? Let's go back to the original equation. 6 to the 1/3 times 2 to the 1/2 equals 12 to the 5/6. What would the general form of this mathematical law look like? Well, we could replace 6 with an x, 1/3 with an a, and then we need to use other variables for 2 and 1/2. So 2, let's use y, and for 1/2, use b. Right, and then the right-hand side of the equation will be xy to the a plus b. Now, if we look in our laws of exponentials, we don't have a law that's written like this. Right? The closest law that we have is the one I alluded to earlier. X to the a times x to the b is x to the a plus b, which isn't applicable in this case because x there corresponds to 6, which would mean that the x here would also have to correspond to 6, but it corresponds to 2. Right, so this rule does not apply in this situation, and in mathematics we have no rule of this type. So anytime a mathematician is rewriting an equation, he or she, in manipulating the equation, has to be able to refer to a specific law or property of the real numbers or integers. Right? Without that justification, the next step can't be taken. So there's the mathematical reason for why 6 to the 1/3 times 2 to the 1/2 is not 12 to the 5/6. And of course, alternatively, we saw earlier, using the calculator, that 6 to the 1/3 times 2 to the 1/2 does not equal 12 to the 5/6. That's called a counterexample, right? So that calculator computation is a counterexample to anyone who would propose this as a rule of mathematics, right? So with that counterexample, we now know that's not a rule, and therefore that's not the correct calculation. So what is the right calculation? Using the least common denominators of the two exponents, we have 6 to the 2/6 times 2 to the 3/6. We can apply one of the laws of exponents to rewrite this as 6 squared times 2 cubed, quantity raised to the 1/6 power, which is, we can rewrite that as the 6th root of 6 squared times 2 cubed, which then, simplifying the radicand, is the 6th root of 36 times 8, which is the 6th root of 288. And that's the final answer.